Okay, my name is James,
Name is Kyle Walker.
and today we're going to be presenting about the observer design pattern. But before we go into the actual design pattern, let's talk about why we would use design patterns in general. Um, let's imagine that there is a team of developers who are tasked to writing a program, and they have two options. They can either use design patterns or not use them. For the team that doesn't use design patterns, they might have a easier time in the short term, but they will definitely suffer in the long term because they're writing non-standard solutions to every problem that they run into, which would make maintaining and interfacing with the code in the future difficult. It would be hard for others to understand what is going on with the code without a good explanation from the original developer, and if the original developer themselves hasn't looked at the code for a while, it could also be difficult for them to understand what their original intention behind their code was in the first place. The number of problems will grow exponentially when the team of developers increase because each program has their own non-standard solutions that they have to explain to anyone else who wants to help maintain or use their code. And it would just be a nightmare to figure out how everything interacts with everything else. Also, as the size of their code base increases, that will also increase the complexity of everything. And overall, everything would just be a mess. Now, in the case of the team of developers who do use design patterns, the opposite would happen. Because they've used in proven development paradigms, they save time in both writing code and reading others' code because they don't have to reinvent the wheel every time a new problem arises. Standardization related to design patterns is very useful in helping to create solutions that are both easy to understand and good at what they do. There's a reason why they're called proven design paradigms. If everyone knows that there is a certain problem that can be solved with a certain design pattern, and that specific design pattern needs like just this or that to function, then it's a lot easier to design code around it instead of coming up with an esoteric solution that could be possibly convoluted and hard to change or understand in the future. Next slide, please. Now, on to the actual design pattern for this presentation, the observer. It is a behavioral design pattern, which means that it identifies and realizes common communication patterns between objects and does so by facilitating a one-to-many communication channel between said objects. This design pattern is commonly used in event-driven programming, such as websites or other web applications. Next slide, please. And now we can move on to an example problem and solution. Say that there is someone who is interested in a new product and they want to know when it arrives at a certain store. They have a number of options to find out when the product arrives at the store. For instance, they can visit the store every single day at a certain time to see if the product has arrived or not. This is similar to having, well, in code, infinite loop that keeps on checking to see if a certain event has happened, and then the loop stops when said event has happened. As you already know, this is pretty inefficient because the majority of the time, the product will not have been at the store or the event will not have happened, and that's just wasted resources. Um, and yeah, next slide, please. Now, the solution to the problem presented would be for a solution for the problem presented would be for the store to create a mailing list where people can subscribe to said mailing list and receive a notification whenever the specific product that they're interested has arrived at the store, or in the case of our code, whenever a specific event has happened. All objects subscribed to the observer will actually be notified, and this is exactly what the observer accomplishes. Now that we've outlined an example problem and solution, we can actually go to some code that um, outlines what's actually going on. Yep.
Okay, so pictured in the slide is a UML diagram which sort of illustrates the code flow of this design pattern. So publisher, which is directly in the middle, is the subject. There are two components to this design pattern, the subject and the observer. Subject's role is to issue an event of interest to any observer. In this case, it's called the subscriber. Observers are called subscribers here. These events can occur under several circumstances. For example, if an executable is performed on the subject and its state is changed, publishers can push out a notification to the subscribers. Publishers contain an infrastructure of subscribers that allows new subscribers to join and leave the notification list. And this is all completely dependent on the subscriber, and they can change it however they want. So when an event occurs, the publisher goes through the subscription list, cycling through it, calling the notification method to the subscriber on each current active subscriber. The subscriber interface is essentially what is in charge of determining the notification interface. Generally speaking, this involves having an update method, which was pictured there. Basically, this just allows the publisher to pass any event details in through an update. It can hold on to any values and may possess several parameters, which is subject to the subscriber's needs or the publisher's parameters. These parameters can vary based on what is necessary for each party. Diving a bit deeper, in the bottom right, the concrete subscribers are essentially an extension of the subscriber class and are not always necessary to make an observer design pattern. These classes perform several actions in response to notifications that are issued by any publisher or subject. All concrete subscribers must be implemented using the same interface so that the publisher cannot be coupled to concrete classes. Multiple layers in the diagram on the concrete subscribers panel indicates the fact that there can be not just one, but several of these classes. The majority of the time, subscribers need a form of contextual information to handle these updates correctly. Just for this reason, publishers often pass some context data as arguments of the notification method. The publisher can pass itself as an argument, and this lets subscribers fetch any required data directly from the publisher. The client is essentially creates publisher and subscriber objects separately and registers both of these as well as updates. All right, and that's basically how this design pattern flows. So here's a code example, and this basically just uses subject and observer, and in this case, the subject is the supermarket and the observer is a customer. And now I'm going to go through each of these methods and just explain what they do and how they play into the observer design pattern. So the supermarket has a list of customers. It's simply a list of observers who are currently on the notification list and allows the system to keep a database of all the current subscribers who are on the mailing list. The state represents the current state of the market. For example, if a new product was released by the market, it would update the state, and this new state would be announced to all of the current subscribers. Now, the get state method simply returns the state of the market. Self-explanatory. The set state method uh, simply changes the state when it needs to be updated. For example, like I said before, if they get a new product in stock, this is how you would physically update the state. It's public, so it could be accessed by um, anyone outside this class. um, the attach method simply calls in the constructor of the customer class, and it basically just adds a new customer to the mailing list of the supermarket and appends it to the list of customers. Notify all customers method is called when the state is updated through the set state method. This basically just notifies all the customers in the list of customers that state has been updated because that is what they subscribe to and just doing their job. Now moving on to the customer class. Constructor here for this class takes in the supermarket that it will subscribe to. Once it's passed in, it calls the attach method to the supermarket class and allowing the customer to subscribe to the current supermarket. And they will now receive updates, and they can choose to stop receiving updates at any time. The update method in this customer class is called, excuse me, it notifies all the customers about the state change. simply prints out the new state notifying customers about the said change. And that is how you implement an observer design pattern into code.
Yeah, here you can see the sources that we've used for this project, and that's about it for this presentation. Thank you for watching.